Given, an integer array, nums, of length n. For each k, build the rotated array arr_k, multiply each entry by its index, add. Return the largest such sum over all k. Example 1, nums 4 3 2 6. Each row is 1k, the rotated array arrk, then f of k written as 0 times first plus 1 times second and so on. Scan the four totals, the largest is 26 at k equals 3. Example 2, 1 2 3. Same layout, each k shows rrk and f of k. The largest total is 8 at k0 and k2. You see the row A, B, C, and D as labels, with f of 0 on screen. One clockwise rotation moves the last label, D, to the front, the order becomes D, then A, then B, then C. Right after that, the on-screen labels will glide into the new order. Take your time and match what you hear to what moves. Below is f of 1 on that rotated row, another full weighted sum. Recomputing every k from scratch feels like restarting the puzzle, we want to reuse the previous sum instead. Stack the middle weights. B and C look like the same letters with coefficients bumped by 1, arrows show that step. The label A is new at weight 1, it was not in the middle strip for f of 0. Let S be the sum of all entries. Adding S to f of 0 is the shortcut that promotes every coefficient by 1, you see 1 times A plus 2 times B plus 3 times C plus 4 times D. After that naive bump, D still acts like it sits at index 4. In the true f of 1, D is at the front, so it should be 0 times D, not 4 times D, subtract n times D to remove the overboost. First build f of 0 the honest way. For each next I from 1 to n-1, reuse the prior value, add the whole array sum, then subtract n times the original entry A at index n-I, that is the value that just rotated to the front. That turns an order n rewrite into an order 1 update. On the sample 4326, walk k0 through 3 with the fast update and refresh the running max. The answer is the largest f you meet along the way, no array of all f values required. Input nums. One pass gives sum of all entries and f of 0 as the weighted index sum. Initialize max f to the current f, gold marks the best value seen so far. Run I from 1 up to n-1. Each step uses index n-I into nums in the update, no physical rotation of the array. First pass, I equals 1, we plug into the formula and get 16. That is below our best of 25, so we do not change it, best stays 25. Second pass, I equals 2, we plug into the formula and get 23. That is below our best of 25, so we do not change it, best stays 25. Third pass, I equals 3, we plug into the formula and get 26. That beats our old best of 25, so we move best up to 26. The function returns max f, the largest rotate score we tracked. Let n be the length of nums. Time is linear in n, one pass to get the total sum in f of 0, then a backward loop with constant work per index using the recurrence. Space is constant beyond the input, we only keep a few integers like sum, f, max f, and the loop index. That beats rebuilding every rotated array and rescanning, which would be order n squared. Main routine, given nums, return the largest rotate function score over all rotations. Let n be the length of nums. Initialize sum to 0 for the plain total of entries. First for loop, walk every index j once. Add nums at j into the running sum. Initialize f to 0 before building f of 0. Second for loop, same range, weighted by index. Accumulate j times nums at j into f, that is f of 0. The running best starts at the initial score. Outer loop, I goes from 1 up to n-1, same as in the solution walkthrough. Each step recomputes f as f plus some minus n times nums at index n-I. If f is bigger than max f, we refresh the best score. Set max f to this f when it is an improvement. Return max f.